we are looking at section 8.5. And I was just doing some more, trying to figure out, the next couple of days. And it looks like you guys are going to have your Chapter A test next Thursday.
Oh my God.
I know you're so excited about it. Okay. Oh, boy. All right. Here we go. So today we are solving more quadratic equations. And yesterday we did, the quadratic formula. The quadratic formula works all the time, and it's great. Today we're going to be factoring and solving, but really I want to talk about completing the square because it's the one that you maybe don't know quite so well. And in fact, the quadratic formula comes from completing the square. We can derive the quadratic formula by completing the square. So the completing the square works all the time as well. We use it a lot in higher math. It's really a powerful tool. And we don't use it so much in the lower levels, so I'm hoping that you get some extra practice on it. And then completing the square is the extra credit for this weekend. So I have already posted extra credit. It's under the announcements on the class website. And it is all completing the square because I want you to get good at it. It's really, really useful. So I want to talk about completing the square a little bit, and I want to introduce you to algebra tiles. How many of you have seen or used algebra tiles before? One.
Is that like Khan Academy?
Is it on Khan Academy? I don't know. I've shown them to you guys. Oh. Yeah. So, all right. So I'm going to show you algebra tiles. Algebra tiles changed my life. I don't consider myself good at math. Okay? I'm a hard worker. Okay? I'm a hard worker at math, but I'm good now. Alright. I just forgot what we were talking about. Here we go. So, when I saw algebra tiles for the first time, I hadn't seen them until after I started teaching, and they really, literally changed my life. Okay, so I want to show you how algebra tiles work. Ladies and gentlemen, this is X. This little stick thing represents an X. Okay, and so if I have another one on there, that would represent two X's. Oh. What's that? Oh, three X's, right? Okay, good. And so when you know that this represents an X, then you can do other stuff with it. So we can add like terms together, and this is what three X's looks like. That's what the representation is, okay? What's nice is, like, for algebra, when I teach Algebra 1, I use these all the time, and so they can really see, like, what do you mean like terms? Well, the exact same shape would be like terms, okay? And we can combine those because they're like things. So we can add, our X's together and have three X's. And not only can we add X's together, but we can multiply. And most of math is multiply. And so if you go back to, your multiplication table, you got that 12 by 12 grid, that multiplication chart, right? And then so if you wanted to do like 5 times 5, and you'd come, where did they come together? And you'd see the number 25, right? But really, there's 25 units. If you counted up all the boxes, right? There's 25 units, right? So multiplying is really just finding an area. So what I would want to do then is say, well, what's X times X? Just like my multiplication chart. Well, what is X times X? Boom. What's that? X squared. I would just like to point out the fact. That X squared is a square. Okay. All right. So I find these things pretty amazing. I think they're really cool. And you might not feel that way, but I do. I'm a math teacher. So, all right. So what I want to do when we're completing the square, completing the square isn't some random process you have to follow. It's actually a literal thing, meaning we are actually completing a square. So I want to show you. For an example here, I have 1x squared plus 6x's. You see it? 1, 2, 3, 4, 5, 6? Yeah? Okay. So this is this representation. When we complete the square, we're trying to figure out what number do I have to add in here so that I create something that's factorable. Meaning, we're finding the length and the width of some rectangle, okay? We're finding the two factors that multiply together to get the thing, all right? So I want to find those two factors that I can write as a perfect square binomial. And so what I do here is I take what I've been given and I rearrange it to form, you know, kind of like a square. That's why it's called completing the square. So, oh, look. Hey, look at that. Right. And so here, right here, what fits right there? 9, right? Look, what are these? Ones. They're ones. How many little ones fit there? 9 of them. So when we're completing this square, we are literally figuring out what do we need to add in so that we get this completed square. Isn't that remarkable? Okay. Isn't that remarkable? Okay. So now that I have this completed square, this is actually what you're doing when you're factoring. We have all these little bits, you know, 1x squared and 6x's and 9 little units to make this rectangular shape. When we factor, we're trying to figure out, well, what times what gives us all those parts? Well, it's a 1x and 3 little units, and another 1x and 3 little units up here. And we can write that as x plus 3 quantity squared, because it's a square. Crazy. Okay. All right, so this is completing the square. And so my question to you is, we started with just the blue and the green x's and x squared. Okay. So my question to you is, how is the 6 related to this 9? What did I have to do with these 6 pieces? So 3 plus 3 is 6. So I took my 6 x's and I split them into 2 groups, didn't I? Yeah? So I'm going to take this b, I'm going to lovingly call it the b value. I'm going to take that b value and I'm going to split it into 2 groups because I got to put half over here and half down here. All right? And then, well, that's 6 divided by 2. That's 3, right? How is the 3 related to this 9? You square it. All right? And so this is how we figure out that missing C value, ladies and gentlemen. Okay? Every time. Okay? Folks, that's completing the square. Was that really eye-opening for you? I think it's really neat. It's something to think about anyway. All right, here we go. So let's actually do some other work. All right. Let's try a couple other things, and then we'll get to completing the square. Yeah. That is for all right, here we go. Example 1, solve by factoring or extracting square roots. Example 1, solve by factoring or extracting square roots. So extracting square roots, the question was, what's extracting square roots? If you have x squared equals 25, How do you solve for x? Use square root both sides. And what do you need to remember when you take a square root? Plus or minus. So anytime you take a square root when you're solving, you want a plus or minus. That's extracting square roots. If we can isolate and take a square root, that's a great method. So letter A, we are going to solve by factoring. All right. If I'm going to solve letter A here by factoring, what do we need to do to be able to do that? We do have to set it equal to 0. That works many, many times. Anytime you have a higher order equation, an x squared or above, we want to set it equal to 0. What do you guys want to do that?
Subtract.
Okay. So some of you said subtract the 5x and subtract the 3. I agree. That's what I would do. How come I'm going to go that direction instead of just moving? Are you okay? So how come I didn't want to move my 2x squared over? I don't want my leading term to be negative. I hate when that leading term is negative, so I would rather move the other things. So 2x squared minus 5x minus 3. And then we can factor. What does factor mean? Double bubble. Thank you. All right. So when we factor, we ask ourselves, what times what is 2x squared? 2x times 1x. 2x times 1x. That's our only option, right? It's not the only one. Negative 2x and negative 1x would also work, but that I don't want to go there. It's not necessary. All right, and then, so last times last has to be negative 3. What times what is negative 3? 1 times negative 3 or negative 1 times positive 3 really are the options. So what should we do? The first one? Yeah. Plus 1 and then negative 3. How do you know if you did it right? Check the rainbow. Very good. We want to check the rainbow. All right, so 2x times negative 3, negative 6x, and then 1 times 1x is 1x. And when we add those together, we get that middle term. So we did it perfectly. Good job. Okay, now that you factored correctly, always double check that you factored that correctly. What do you do from there to solve? How? Set each bubble equal to 0. Set each bubble equal to 0. This one's easy. X equals 3. And over here, we get 2x equals negative 1. And divide by 2, we get negative 1/2. So, all right. So set each bubble equal to 0. Great way to solve. Okay. You all know how to do that. Over here, we can take square roots. You'll notice I don't have I have this whole thing that almost functions just like the x here. That's being squared. And because of that, I can use the square root method. What should you do first if you're going to use the square root method? Add 7. You need to isolate the thing that's being squared. So I have 2x minus 1, quantity squared equals 18. And then, how do you get rid of the power? Square root. What do you need to remember when you take the square root? Plus or minus. Plus or minus. Plus or minus. So that is going to cancel out our square, leaving the guts of the equation. And then, how do you simplify that radical? 3 radical 2. Very good. This is the square root of 9 is 3, and the square root of 2 does not simplify, so 3 radical 2. And then what should we do? Add 1, and then divide by 2. Okay, and divide by 2. I'm going to divide everything by 2. So we get 1/2 plus or minus. Can I write 3/2 radical 2? Is that allowed? It is, in fact. Can you leave it 3 radical 2 over 2? Yeah, that's also allowed. Yes. The whole thing, 1 plus radical 3 over, 2, 1
Oh, you can't do that.
plus
So here's-
3 root 2 over 2 is also correct. As long as that division bar goes all the way across. Yeah.
Oh.
All right, lots of different ways to write that. So yeah. The reason that I split it up is always just so it helps me reduce properly. That's it. To get the x by stuff? Okay, good. Here we go. So here's the more challenging part. Example 2. Solve by completing the square. You really need to pay attention to this. I'm only doing one of these because I think you've had this before. Again, you might not be super at it, but you're going to get you can do a whole extra credit worksheet on it. So what I've done here is this is actually the hardest it gets, almost the hardest, I guess, in terms of this type of problem. Usually it'll be a little easier. But if you need some more examples, you can look on page 854. There's some more examples if you want to look at those. All right, so the first thing here is when I did my little thing with algebra tiles, I only had a 1x squared. And that's actually really important because I cannot complete the square when there is a coefficient other than 1. So my very first step for completing the square is to divide through by a. Whatever that a value is, that leading term. If it's a 1, you divide through by 1. Is that going to change anything? No. But you definitely have to do that. Divide everything through by 3. Is that allowed? Is it legal to do that? Yeah, as long as I do it everywhere, it's allowed. So that gives me x squared minus 4/3 x minus 5/3 equals 0. And then what I want to do to complete the square, sort of the easy way to do this, is to move the constant term. What is a constant term? It's the C. Yeah, it's this one. Why is that 5/3 a negative 5/3? Why is that called constant?
So it's always going to be the same number.
It's always the same versus something that would be variable. So yeah, anything multiplied by an x or anything that has an x, that x can vary, can't it? We don't know what that x is, right? It varies. All right? So if we take a number and multiply it by x, that would be called something that varies. It changes, doesn't it? Versus something that is constant, that remains unchanged. Okay? So we're going to go ahead. I'm going to move that negative 5/3 to the other side. And I'm going to add some blank spaces. So I'm going to do x squared minus 4/3 x. I'm going to put in a blank space because I need to figure out what number goes in that blank space. That's that C value I'm looking for that completes the square. So C for complete the square. So we're going to figure out what that C value is. So C, how do you calculate that C value?
B over 2 squared.
B over 2 quantity squared. Careful there, don't confuse it with finding the vertex, which is negative B over 2A. So I'm going to write it a little differently than B divided by 2. Is it the same thing to say half of B squared? Yeah. So B over 2 or half of B. And the reason I'm saying half of B is because I have a fraction, and that's going to be a lot easier to just take on half. So 1/2 times this new B value. I'm going to give that a capital B, whatever that new B is. Right here, there's our B. So half of negative 4/3, and I need to square it. What's half of negative 4/3? Negative 4 over 6, if you will. Negative 4 over 6, which reduces to negative 2/3. And what is negative 2/3 squared? 4/9. Negative 2/3 times negative 2/3 is positive 4/9. So this is the C value that we get to add in. Now, how come I had to add that blank to both sides of the equation? So it stays the same, right? We have to keep our equation balanced. So I can't just add that C value on the left-hand side because now I've added extra weight to that left-hand side. I need to make it balance out. So I need that 4/9 on the right-hand side also. By doing that, we are now able to factor the left-hand side in this case. We have a trinomial that we can double bubble. What times what is x squared? Oh, x times x. Okay, second question. What times what is 4/9? Yeah, always this thing right there. Negative 2/3 times negative 2/3. And when you add those together, you know, check your rainbow. Negative 2/3 and negative 2/3 is negative 4/3. All right. Now, that's a perfect square, so I'm just going to write that as x minus 2/3 quantity squared is equal to, I need to add my 5/3 and 4/9 together. What do we need to do to add those? Yeah, get a common denominator. So I'm going to multiply that 5/3 by 3. That becomes 15/9 plus 4/9, which is 19/9. Oh, I didn't hear a thing. Oh, you know what? He's not here. No, yes, he is. Oh, just kidding. You're good. You're good. All right. All right. Now, how do we solve for x? How did I get the? Five thirds, I multiply top and bottom by 3 to get common denominator. All right. What should I do next? Square root. All right, we're going to take the square root of both sides. What do you need to remember when you take a square root? Plus or minus. Very good. So the square root and the square cancel out. So we have x minus 2/3 equals plus or minus. Now, the square root of 19 over 9, that square root breaks apart. You can take the square root of the top and the square root of the bottom. Can I simplify 19? That works. Yeah, so I would say radical 19 over 3 works. 1/3 radical 19 is the same. Yeah. And then how do we get x by itself? Add the 2/3. So we get x equals positive 2/3 plus or minus radical 19/3. Now, I will say that on your homework tonight, there's definitely one question, number 79, that is, your book is always going to rationalize. So if you ended up with, like, I don't know, let's say you're taking the square root of 16 over 5. The square root of 16 over the square root of 5. Well, I know the square root of 16, that's 4. But I can't do anything with that radical 5, can I? So how do you rationalize? Multiply top and bottom by radical 5. And so you would get 4 radical 5 over 5. Radical 5 times radical 5 is radical 25, which simplifies to just 5. Yes, sir.
If like on the test we had radical 65th, would it be wrong?
Well, so here's the problem. So the question was, if I have radical 16/5 on the test, is it wrong? My tests are multiple choice. My answers will always be rationalized. If you know that that is really the same as that, then you're good to go. Okay. What I will say is that can you put this into a calculator and get a decimal approximation? Mm-hmm. And then if you see something like this, could you plug that into your calculator and get a decimal approximation?
Yes.
Okay. And should those decimal approximations match?
Yes.
Yes, they should. Okay. So when in doubt, rough it out. Plug it out. Okay. All right, ladies and gentlemen, do you have any questions for me? All right, get to work.